In this video, we're going to learn how to take the derivative of a function involving natural logarithms. So to the right, you see the basic fact that the derivative of the ln of x, right? The derivative of the natural logarithm of x is equal to 1 over x. So that's a known fact, and we're going to use this fact when we take the derivative of a more complicated function. So the function that we're going to be starting with is going to be ln 4x squared. Okay, so the derivative of that. Notice that first of all, I'm just going to estimate the derivative of the given one, and then I'm going to show you another way. So the derivative of this is going to be first starting from the inside, which is the ln, so we have to differentiate the ln. So we're going to take, using this fact here on the right, 1 over 4x squared multiplied by the inside, multiplied by the derivative of 4x squared, right? That's going to give us 1 over 4x squared multiplied by the derivative of this, and derivative using the power rule is going to be 2 times 4, that's 8, and then x to the first power, right? Because the power decreases. So that should simplify as 8 over 4 is 2, and x over x squared is 1 over x, so it's going to be 2 over x. Now, what did I want to show you? There's another way. Notice that ln of 4x squared can be written as 2 ln 4, okay, using the algebraic property of a natural logarithm, or any logarithm. Right, so the 2 can be brought up as the coefficient here. ln 4 can be by itself. ln 4x. Yeah, so it can be brought in by itself. So now we can take the derivative of this, and it should give us the same result. Right, so let's take that. So 2 goes as a constant out. Right, so 2 derivative of ln 4x. Right. And that should give us 2 multiplied by differentiating the ln, so 1 over 4x, multiplied by the derivative of 4x, which is going to be 4. Right? So that should give us 4 divided by 4 is 1, 2 times 1 is 2. And so 2 remains over x. See? Same exact result. Okay, let's talk about a more complicated example. It's not that much more complicated, but it's a different function. So ln of cosine of x. Okay, so again, write that a little clearer. So again, notice that first we have to differentiate. We have to differentiate the ln first. We have to differentiate the ln first, right? So we're going to do 1 over cosine of x multiplied by the derivative of the cosine, which is going to be negative sine x, right? And that should give us negative sine x over cosine of x. And that, as you should recognize, is negative tangent of x. Okay? Now the last example is going to involve using the chain rule several times. So the function will be sine of ln of cosine x to the third. Okay, so the derivative of that, the derivative of this function, which consists of several functions as you can see, is going to be starting. Notice that when you use the chain rule, you always start from the outside, right? You first differentiate the outermost function, and then you work from the outside to the inside, right? So you start from the outside. So the derivative of the sine is going to be cosine, right? And when you take the derivative of the outside functions, the inside functions remain the same, right? So the cosine, and then ln is copied down, and so is the cosine x to the third. And then multiplied. Now we're going to take the derivative of the ln, so using the on the top right hand corner, we're going to have to take 1 over cosine of x to the third, right? Because now we're doing ln. So now we're going to differentiate the cosine, so that's going to give us negative sine x to the third. Okay, and then finally we're going to differentiate the x to the third itself, so it's going to give us 3x squared. Pretty complicated, right? But let's see what we get. So then we're going to have, I'm going to copy the negative sign and the 3x squared first. So I'm going to do negative 3x squared sine x to the third cosine ln cosine x to the third, divide this whole thing by cosine x to the third. And notice that this can still be simplified because sine of x to the third divided by the cosine of x to the third is precisely tangent of x to the third, right? So we're going to get negative 3x squared tangent x to the third cosine of ln of cosine x to the third. Okay, so that's your final answer. And this is the derivative of the original stack of functions that we started with. Okay, so hope you enjoyed this tutorial. Please subscribe to my channel, and I'll see you in my next video.